Hello, and welcome to part 3 of the IAM Policy Evaluation video series, where we'll talk about policy evaluation chains. This is an advanced topic, but an important one if you're someone that writes resource-based policies. My name is Matt Luttrell, and I'm a Principal Solutions Architect in AWS Identity. Let's get started. I'll start today by introducing a model for understanding policy evaluation, which shows you how different IAM policies work together to evaluate a request. We'll then use that model to compare different ways of writing resource-based policies. And lastly, I'll provide some practical guidance on ways that I recommend to use the principal element in your resource-based policies. Since this video covers more advanced topics, there are a few things that you should know before getting started. You'll first need a general understanding of IAM policy syntax and the policy matching semantics. You need to understand what a resource-based policy is and how resource-based policies differ from identity-based policies. If you need a refresher for any of these, see part 1 of this video series. You'll also need a general understanding of the other types of IAM policies, such as permissions boundaries and service control policies. Our focus in this video is on how these policies come together to make an authorization decision. We won't talk much about the situations where you should use each policy type. Before we can understand how requests are evaluated, we need to talk about the different types of principals that make requests. The first principal that makes requests is the role session. A role always has a corresponding session, which is the principal that actually makes the request. An IAM role by itself does not make requests without a session. Most of the examples in this presentation will focus on the evaluation of requests made by IAM roles. The next principal that makes requests is an IAM user. IAM users do not have sessions and they do make requests themselves. We also have what we call a federated user. And a federated user is a principal that has received credentials by using the STS Get Federation Token API. This is not a user that is federated by way of an identity provider. Most customers won't use this type of federated user often. Next, we have an anonymous principal, which is a principal that makes unauthenticated requests to AWS. And then we have the root user, which is a special type of principal that you should not be using for everyday tasks. The root user has full access to your AWS account. Most of this video will look at the policy evaluation logic for requests made by IAM role sessions, which share the same logic as requests made by federated users. We'll touch briefly on how IAM users are slightly different here. With that in mind, let me introduce policy evaluation chains. Here's a look at a sample policy evaluation chain for a request made by an IAM role session for a resource in the same account. An incoming request flows from left to right in this model. As the request travels from one orange node in the chain to the next, the request is evaluated against the policies shown in white, using the policy matching semantics that we discussed in earlier videos in this series. For a request to be allowed, every policy in the chain must explicitly allow the request. If any single policy does not have a matching allow statement or has a matching deny statement, then the request is denied. Let's walk through an example. We start at the organization and evaluate the request against the service control policies attached to the organization. If access is allowed by the service control policies, we move on to the account and evaluate the request against any identity-based policies attached to the principal. If the identity-based policies allow access, we evaluate the request against any permissions boundaries, if any are attached. And finally, we evaluate the request against the session policy associated with the role session. Every role session has a session policy. If you don't specify a session policy when you create a role session, it defaults to allowing all actions and all resources and acts as a pass-through. In other words, the default session policy says to trust the results of the upstream policies and let the identity-based policy and permissions boundary decide what the principal can or can't access. If each policy in the evaluation chain allows access, then the request is allowed. Not pictured here are VPC endpoint policies, which I excluded to simplify the model. VPC endpoint policies function similarly to service control policies in the evaluation chain, but are only evaluated when a request passes through a VPC endpoint. You may have also noticed there's a new concept of a boundary pictured here. And this is just a virtual representation of the principle that the permissions boundary is evaluated against. It's not something that you could put in any kind of IAM policy. You can, however, use the values for the three boxes that you see highlighted as values of the principal element of an IAM policy: the account, the role, and the session. Before we go any further with this model, I want to take a brief aside to talk about how service control policies are evaluated in this highlighted portion of the evaluation chain. Let's use this organizational structure for our example and assume that our policy evaluation is being done within account 1. When a principal from account 1 makes a request, IAM will grab the service control policies for account 1, OUA, and any service control policies attached to the root node. IAM then evaluates each level of the organizational hierarchy independently. There must be a matching statement with an effect of allow in a service control policy attached at each level of the organizational hierarchy for the request to be allowed by your service control policies. The request then continues on to the rest of the policy evaluation chain. Once we reach the account node in this image here, we can zoom back out and continue to evaluate our request against the rest of the policy evaluation chain. So whenever you see a request pass through the white bar labeled SCP, shown highlighted here on your screen, you should understand that there are multiple evaluations, one for each level of the organization's hierarchy, that occur in this step. The model hides those evaluations for you in order to keep it simpler. One additional thing to call out is that service control policies are only evaluated if the principal making the request belongs to your organization. It's important to keep that in mind when we start talking about resource-based policies, which have the ability to allow and deny requests for principals outside of your organization. We're going to use this model to refine the two rules of policy evaluation that we introduced in the first video of this series. The first rule now says, at least one statement with an effect of allow for all policies in the evaluation chain must match for a request to be allowed. In the first video, we only dealt with a single policy type. In this video, we'll show you how all of the policy types work together to make an authorization decision. The second rule of policy evaluation remains the same and states that a matching statement with an effect of deny in any policy, regardless of if that policy is part of the evaluation chain, takes precedence over a matching statement with an effect of allow. With that in mind, let's go back to talking about policy evaluation chains. And this time, we'll add resource-based policies. It's important to note that everything we talk about in this particular section is still for a request that is made where the principal and the resource are in the same account. Here's what our evaluation chain looks like when we introduce resource-based policies. The resource-based policy is represented by this orange box here at the top of the model. You can see that the resource-based policy has three arrows coming out of it that point to the account, the role, and the session. These arrows represent the paths that a request can take through the policy evaluation chain for requests within the same account. The path that a request takes depends on the value of the principal element in the resource-based policy. The model also shows that a request can reach the session by following the path directly from the organization to the account. This is shown by the bottom arrow coming out of the organization node on the left. The path on the top travels through the resource-based policy and follows the arrow that matches the value of the principal element in the resource-based policy. The bottom path that starts with the account is linear, does not change, and runs through all of the policies attached to the principal. For a request to be allowed, at least one of the paths to the session must contain explicit allow statements in all policies in the chain. An explicit deny in any policy, regardless of if the policy is part of the chain, results in the request being denied. So what are the possible values you can use for the principal element in a resource-based policy? And when I say principal element in this video, I'm referring specifically to the AWS principal type. There are a few other principal types, but I'm going to focus on the AWS principal type for this video. A wildcard value specifies all principals. Be very careful when using a wildcard value in a policy statement with an effect of allow. Unless you need to grant public access to your resources, this should only be done when combined with an appropriate condition key. A reminder from our first video that a wildcard by itself is the only valid use of a wildcard in the principal element. You can also choose to use the account in the principal element, and both of the representations that you see here are the same. You can choose to use either. Then we have the role, which allows you to specify a specific role that should have access to the resource. This could also be an IAM user. And lastly, you can choose to specify an individual role session in the principal element, though you should typically prefer using the role over the session in your principal element in most situations. The possible values here correspond directly to the boxes in the model that we just showed on the previous slide. So the value that you choose here is important. It defines which policies IAM looks at for matching allow statements when authorizing a request. Let's walk through some examples to help you understand this behavior. Let's start with what our evaluation chain looks like when there's no allow in a resource-based policy on the resource. And in this case, you can see that the only path available that the request can take is the one directly to the account. There is no path through the resource-based policy. IAM evaluates each of the policies in the policy evaluation chain against the authorization context of the request. If there is a matching allow statement in every policy in the chain and no matching deny statement, then access is allowed for that request. Okay, let's look at an example where we do have a resource-based policy with an allow effect that looks something like this one. This is an S3 bucket policy where I've specified the account as the value of the principal element. Don't worry about anything other than the fact that this policy has an effective allow and what the value of the principal element is. The rest of the policy statement is not important to your understanding of this model. This time, there is a matching allow statement in the resource-based policy. You'll see that when IAM evaluates this request, that there is now a path through the resource-based policy. The request then follows the arrow that corresponds with the value of the principal element, in this case, the account. And once again, if we have a matching allow statement in all of the policies that make up the evaluation chain, then access is allowed. Now it turns out that the path through the resource-based policy ends up being identical to the path that the request can take directly through the account, independent of the resource-based policy that you're seeing here. So generally speaking, there's not really a reason to use the account ID as the value of the principal element in a resource-based policy with an effective allow if the resource and principal are within the same account. KMS key policies and IAM role trust policies are two exceptions to this rule that we'll discuss later. Now let's look at what happens when we have a statement with an effect of allow that specifies an IAM role as the value of the principal element in that same S3 bucket policy. When the value of the principal element is a role and the resource-based policy allows the request, the path through the resource-based policy changes, following the arrow to the role. Now, what does this mean? It means that this path no longer travels through or requires a matching allow statement in an identity-based policy. IAM will still look for a matching deny statement in an identity-based policy, and the request will still be denied if a matching deny statement is found in the identity-based policy or in any other policy. But we can see here how the value of the principal element impacts how the request is evaluated. Now, here's an example where we have a resource-based policy that allows access to some other role. We would say that we have an implicit deny in the resource-based policy. Let's see how this request looks to our model. The model first attempts to follow the path of the resource-based policy. But since there's no matching allow statement, this path stops here. There is, however, still a path for the request to take directly to the account and through the identity-based policy. We only need one path to the session with matching allow statements in all policies in order for our request to be allowed. Lastly, let's look at what happens when the value of the principal element is the role session ARN. As I mentioned earlier, this is not something that you typically want to do, but it's important to show you how it behaves. When the value of the principal element is the role session and the resource-based policy allows the request, the path through the policy evaluation chain changes and follows the arrow directly to the session. This means that IAM does not need a matching allow statement in the identity-based policy, the permissions boundary, or the session policy. The only matching allow statement that's needed is in the service control policies and in the resource-based policy. It's worth repeating here that explicit denies in any of these policies will still result in the request being denied, even if they are not part of the path that the request takes through the chain. Let's take a look at what happens if we have that same policy where the role session ARN is the value of the principal element, but instead we have an explicit deny in a permissions boundary. You can see that IAM finds a matching deny statement in the permissions boundary and the request is denied. IAM will look for matching deny statements in all policies, even if they are not part of the path that the request takes through the evaluation chain. If you make use of permissions boundaries in your environment, you may want to consider adding explicit denies in them for this reason. I mentioned that KMS key policies and IAM role trust policies are different. For both of these resource-based policies, there's only a single path from the organization and therefore only a single arrow in our model. Said differently, there must always be an allow in the resource-based policy for KMS key policies and IAM role trust policies. If there is no explicit allow in the resource-based policy, the evaluation ends with an implicit deny. You can see that there is no alternate path from the organization to the account for KMS key policies or IAM role trust policies. Because of this, when you write KMS key policies or IAM role trust policies, it can make sense to use an account ID as the value for your principal element for access within the same account. Let's see what that looks like in our model. The allow in the resource-based policy, with the value of the principal element as the account ID, allows the request to continue to the account node and follow the path through all of the IAM policies. This pattern requires an allow in an identity-based policy, and you'll often hear it referred to as the KMS key policy delegating access control to IAM. So up until this point, we've only talked about IAM roles. An evaluation chain for an IAM user has a few differences. For one, there's no session involved in the request. And secondly, the order of the evaluation of the permissions boundary and the identity-based policy is switched when compared to an IAM role. The permissions boundary comes before the identity-based policy in the chain. Now this has some implications when it comes to resource-based policy evaluation. Here we have our familiar bucket policy, but this time we've specified an IAM user as the value of the principal element. And let's see what happens. When we look at the evaluation chain for an IAM user, we see that if we specify the user as the value of the principal element, there is a path where IAM does not require an allow in the identity-based policy or the permissions boundary. The same rules with explicit denies apply here. IAM will still look for an explicit deny in any of these policies. The examples you've seen until now have all been for evaluation where the principal and the resource are within the same account. Now let's take a look at how cross-account requests are evaluated. For a request to be allowed across an account boundary, the resource-based policy in the resources account and the evaluation chain in the principal's account must both allow access. The value specified in the principal element of the resource-based policy when access is cross-account defines which principals can access the resource, but does not modify the evaluation chain like you saw for requests within the same account. So if I specify an account ID in the resource-based policy of my resource, that means that any principal in that account can access my resource if that principal also has a path through the evaluation chain in their account that grants access. If I specify a specific role, then only that specific role can access my resource. And if I specify a role session, then only a role session with that specific name can access my resource. An important reminder when writing resource-based policies for cross-account access is that your service control policies only apply to principals in your organization. If a principal from another organization makes a request to your resource, your service control policies will not affect that request. To recap, for cross-account access, the story is a bit more straightforward. The account with the resource must grant access to the principal in the other account using a resource-based policy. The account with the principal must have a path through the policy evaluation chain that allows access to the resource. This means that all of the policies that make up the evaluation chain must allow access to that cross-account resource. The principal element of the resource-based policy defines what principals can access the resource or the scope of access, but does not modify the policy evaluation chain. Let's move on from talking about the model and start looking at some practical applications. Here's an example of a bucket policy that we've seen already, where the role is defined as the value of the principal element. Again, we're just focused on the principal element value for now. So take that same bucket policy, and what happens when the role that we referenced in the policy gets deleted? You may have seen something that looks a little like this in your resource-based policies at some point. This string that starts with AROA is the unique ID of the role. When you save a resource-based policy that references a specific role's ARN, that ARN gets translated to the unique ID of the role behind the scenes. And this is to tie the resource-based policy to a specific instance of an IAM role. This helps protect against the case where you delete a role and someone else comes along and creates a role with the same name. The trade-off here is that if I need to delete and recreate a role for a valid reason, like needing to change a property of the role that requires recreation, that I also need to go and update all of my resource-based policies that reference that role after I recreate it. Now, this behavior may not always be what you want. Let's say that the role you're referencing in your policy is a role in an external account that belongs to a trusted third party. You might not have any control over when they delete or recreate their IAM roles. Once the role referenced in the resource-based policy is deleted, the policy statement no longer works for that role by design, and you cannot save the policy until you remove the statement with that AROA identifier that you see here. So what else can you do? This statement also grants access to a specific IAM role. The difference is that this example uses the AWS principal ARN condition key combined with the account ID in the value of the principal element. This policy is not impacted if a role is deleted and recreated. And the trade-off in this case is that there is a risk that someone else could create a role with the same name and have access to your resource. So you need to think carefully about which risk is more important to you in which situation. If you want to allow access only to a specific instance of an IAM role, then you should specify that IAM role in the principal element. If you want to ensure that the policy statement still works, even if the role were to be deleted and recreated, you can use the AWS Principal ARN condition key as you see here. Note that this policy statement is not exactly equivalent with the previous policy. This policy statement still requires an allow in an identity-based policy because the value of the principal element is the account ID. This makes this policy statement generally only useful for cross-account access or same-account access with KMS key policies and IAM role trust policies. Moving on. So let's take a look at some more examples and try to tie them back to our model. These two policy statements look very similar, but they are slightly different. The top statement uses the account as the value of the principal element, and the bottom statement uses a wildcard. Both statements use the AWS Principal ARN condition key to restrict access to a specific IAM role. Now, for cross-account access, these two statements are effectively the same, though I'd still recommend the use of the statement that uses the account ID in the principal element just to avoid the use of a wildcard principal element. For requests where the principal and the resource are within the same account, there are some interesting differences in how these statements evaluate. Let's take a look. Let's first take a look at what our policy evaluation model looks like when we have the account in the principal element. Remember that we've also included a condition key that scopes this policy down to a particular role as well. So this request takes the same path through the evaluation chain that it would if there were no resource-based policy. All of the policies shown need to allow access for access to be allowed. Now what happens when we instead use a wildcard as the value of the principal element for access within the same account? Remember again that we do have the AWS Principal ARN condition key, so access is still limited to a specific role. Since a wildcard as the value of the principal element matches all possible principals, there are 4 possible paths the evaluation can take through the chain. The first path does not involve the resource-based policy at all and follows the arrows to the account and through all of the policies attached to the principal. The second path looks at the wildcard value for the principal element and follows the first matching principal through the account. Path number 3 follows the next matching principal, the role, and you can start to see the differences. This path does not require an allow in an identity-based policy. And path number 4 matches our last principle in the model, the session. This path does not require an allow in an identity-based policy, a permissions boundary, or a session policy. IAM will consider each of these paths, but only one of these paths needs to grant access for access to be allowed. Path 4 that you see here is the path that requires the fewest amount of policies to allow the request, needing only an allow in the service control policies and the resource-based policy. To summarize, this means that for access where the principal and the resource are within the same account, when using a wildcard in the principal element, an IAM role would not need an allow in an identity-based policy, a permissions boundary, or a session policy for the request to be allowed, even when that wildcard in the principal element is constrained by a condition key, like we saw in this example with the AWS Principal ARN condition key. Remember that this is only true when both the principal and resource are within the same account. And also remember that IAM will still look for matching deny statements in any of the policies, regardless of if they are part of the path or not. Before we move on, I want to call out that there are only 4 possible values for the AWS Principal ARN condition key in the authorization context. The value you should use depends on the type of principal that is making the request. This value remains the same throughout the authorization of the request, even as the request is compared against different policy types. So for an IAM role, the AWS Principal ARN value remains the role's ARN in the authorization context throughout the authorization of the request. The not principal element. We touched on the not principal element in the first video of the series. Let's revisit the topic now that we have an understanding of the policy evaluation model and can reason about why it behaves the way it does. Let's start with a reminder that you should not use the not principal element with an effect of an allow. Why? This allows every other principal except for the one you specified. This is almost always not what you're intending to do, and this is effectively granting public access to your resource. Do not do this. With that out of the way, let's take a look at the not principal element with an effective deny. The author of the policy that you see here intended to explicitly deny all principals except for my role. But this doesn't work. Think back to our policy evaluation model and ask yourself why not. There are 4 possible values for a principal element that get substituted into the authorization context for each request made by an IAM role. This policy statement only excludes one of those values, the role. The not principal element didn't include the account, the boundary, or the session shown here in red. And there are 4 possible principal elements involved in this request: the account, the role, the boundary, and the session. The only principal element that we excluded in the not principal element was the role. This means that access is still denied for the account, the boundary, and the session. And we said that an explicit deny anywhere in our policy evaluation chain results in a denied request. So any request to this resource would end up being denied. Now, what happens if we exclude multiple different principal values from our policy? Here, we include the account, the role, and the role session. And this works in some cases, but this won't work if you have a permissions boundary attached to the role. Then you'd still be denied access regardless of what was in the permissions boundary, because this introduces the boundary principle that you can't put in a resource-based policy. But don't worry, there's a better way. We go back to our friend, the AWS principal ARN condition key. Since condition key values in the authorization context don't change as we move through the policy evaluation chain, the value for the AWS principal ARN condition key will be the ARN of the role at each step in the chain. So this resource-based policy works to deny everyone except for the role that we specify. And you could add additional roles as values for the AWS principal ARN condition key as well. You can also use a wildcard somewhere in the condition key value, which is something that you can't do in the principal or not principal elements. The takeaway from this section is that you should prefer the use of the AWS principal ARN condition key over the not principal element. Especially avoid using the not principal element in a statement with an effect of allow. I've told you that the value you specify for your principal element is important, so what value for the principal element should you actually use? We'll start with principal values for cross-account access. For granting cross-account access, I generally recommend one of these 3 options in a policy statement with an effect of allow. The top option trusts the entire to's account, which we're considering an account that's external to our resources account for this example. This statement has no attached condition keys. The middle and bottom options both trust a specific role in the account, but do so in a different way. Note that I'm only showing the principal and condition elements of these policy statements. These aren't valid statements, and you would still need to fill in the action, resource, and effects for these policies, but I want the focus to be on these elements of a policy statement for this section. Let's take a look at each option, starting with the first option, trusting the entire account. The benefit of trusting the entire account is that you can avoid the potential availability issue that could happen if you were to specify a role as the value of the principal element. This availability issue is the one we discussed earlier that occurs if the external account deletes or recreates the role. As you saw, the role's unique ID would then show up in the policy, and the external account would no longer have access to the bucket. Trusting the entire account can be useful in cases where you don't own the account that you're granting access to. If you think about it, you probably have some level of implicit trust to the entire account, regardless of what you put in the policy. because you often have no control over who can assume what role in that external account if you don't own that external account. The second option is trusting a specific role by placing the role in the principal element. Trusting a specific role in an external account can be useful if you own the account you're granting access to. This means that you do have control over the creation and deletion lifecycle of that role, as well as the security controls that prevent it from being assumed by other principals in that account. This makes it less likely that the role will be deleted or recreated, which may cause an availability issue. Or, if you do need to delete and recreate the role, you have total control over the timing and can make an update to the policy. Lastly, this policy is a combination of the two previous policies. This policy uses the all2s account number as the value in the principal element, but also uses the AWS principal ARN condition key to specify a specific role that is allowed access. This means that if the role is deleted and recreated, then the policy will still grant access to the role. The risk that you accept when you use a policy like this is that it's possible for someone else in the all2s account to create a role with the same name if the original role were deleted and not recreated. This can also be a useful pattern if you own the account you are granting access to and have controls that ensure that no one else can create a role with the same name. There are legitimate use cases where you may need to recreate a role, such as the modification of certain properties of that role, or even accidental use cases where your infrastructure as code ends up deleting and recreating a role. What if you need to grant access to a resource to your entire organization? This is one of the few times that I recommend the use of a wildcard in the principal element. And this can be a useful policy if you have something like an SNS topic or an S3 bucket that should be available to anyone within your organization, but should not be publicly available. This policy includes two conditions. The first condition says that principals making a request to this resource must belong to a specific organization, and that's this O-example in this policy. The second condition is interesting, and it says that this policy does not apply if the principal is in the same account as the resource to which this policy is attached. Why are we doing that? Remember when we walked through the behavior of a wildcard as the value of the principal element for same account requests earlier in this video? Since a wildcard matches all principals, this statement would grant access to all principals in the same account without requiring the principals to have an allow in an identity-based policy if we did not include this condition. So we add this condition that says that this statement does not apply for principals in the same account to avoid this behavior. I do recommend writing a policy statement like this for organization-wide access, and then writing a separate statement if principals in the same account need access to the resource. Or for same account access, you can just rely on identity-based policies. Speaking of same account access, what principles should you use in a resource-based policy for that? Firstly, many customers will choose to exclusively use identity-based policies for granting access to resources within the same account. The benefit to doing this is that you only need to look at your identity-based policies to determine what access that identity has. If you do decide to use resource-based policies for same account access, you're primarily going to be using the middle option here, where you specify the role as the value of the principal element. Remember from our model that you do not need an allow in an identity-based policy when you do this. If you're working with an IAM role trust policy or a KMS key policy, you can also use either the top and bottom options with the account number as the value of the principal element. These options can be useful if you still want to require the role to have an allow in an identity-based policy to be able to access the resource. These options are often described as delegating access to your identity-based policies. To summarize, the principal element value that you use for same account access depends on where you want to manage that access. If you want to manage access in your identity-based policies, you can choose to avoid adding an allow in a resource-based policy altogether and use the top or bottom option here for KMS key policies and IAM role trust policies. If you want to manage access in resource-based policies, you're probably going to choose the middle option here and specify a role as the value of the principal element. Throughout most of this talk, we've ignored the presence of VPC endpoint policies, primarily because they evaluate similarly to service control policies. One important thing to note about VPC endpoints in particular is that there are additional condition keys that you can use in your policies that are only available when the request passes through a VPC endpoint. These are keys like AWS Source VPC and AWS Source VPC-E. The IAM documentation will tell you when a condition key relies on a request passing through a VPC endpoint to be available. Here's a quick look at how VPC endpoint policies fit into the policy evaluation chain. If there is a VPC endpoint policy present and the request is made through the VPC endpoint, you can see that they function similarly to service control policies. VPC endpoint policy statements with an effect of allow will generally use a wildcard principle with some conditions attached. This just means that the VPC endpoint will pass all principles through to the next policy in the chain, as long as it meets the conditional criteria. VPC endpoint policies typically act like a filter. The VPC endpoint policy shown here ensures that only principals that belong to my organization can make requests through my VPC endpoints. VPC endpoint policy statements with an effect of deny are also usually written using a wildcard as the value of the principal element. This policy statement also denies access unless the principal making the request belongs to the organization that I specify. If you use a deny statement like this, you will also need a separate statement that allows access. And with that, we'll wrap up this video. We went over a lot today. And 3 practical takeaways from this video are that 1. The value of the principal element in a resource-based policy can impact how IAM evaluates a request by modifying the path through the policy evaluation chain. Remember that explicit denies are always honored, even if they are not part of the evaluation chain. The not principal element should generally be avoided. The AWS principal ARN condition key is what you should use in its place. When choosing what value to use in the principal element of a resource-based policy, think carefully about your trust model. Be extra careful when using a wildcard in the principal element, even when paired with additional condition keys. Thank you, and I hope to see you again in the next video.